Hello, welcome to Point On Studio. My name is Jung Park. Today I'm going to continue using RhinoInside, but specifically for infrastructure such as bridge design. We're going to use SOFiSTiK plugin for Grasshopper to create parametric bridge design, and the Grasshopper output we're going to transfer to Revit native family elements using RhinoInside. I think just because Revit has a little bit of lack of infrastructural capacity, so I found out that this SOFiSTiK for Grasshopper plugin is really great tool to create such a large infrastructure. So let's take a look today, and I think this tutorial is going to be a little bit perhaps complicated than the tower design we did last time, but I guess it will be more fun. Just notice that I'm not structural engineer for bridge design. I'm architect, so maybe some of the bridge component I create may not make sense for the structural engineering, especially for the bridge engineers. But just take a look at the potential, how you can create calculation model out of SOFiSTiK and construction model using RhinoInside to transfer all the elements as a BIM component. Alright, let's get started. So if you look at this Revit file, this is the output I generate the bridge model out of Grasshopper definition. As you can see, this bridge to design in Revit or model in Revit, it's like a really big challenge because it's really curved and all the direction is different, and every elements are kind of different components. And also in this video, I'm going to show different techniques using adaptive component and also using just typical family insertion, so we can control the level of detail, especially these bearing components. I'm showing you it's set for roughly like a rolling bearing for the bridge, and which is nested into our main bridge component here. Alright, so if you look at the Grasshopper definition, we have here from RhinoInside, all the components are actually coming out of the data output. So we're going to use the same technique as the video I show for the parametric tower. If you haven't watched it yet, you can check it out from the link up there. And we'll use the same technique using data output, input and output. So the main script, this is the parametric bridges. Basically, we getting the model out of SOFiSTiK plugin. And if you look at the main script, it's quite complicated. And by the way, to use this example, you need to have a SOFiSTiK plugin for Rhino and Grasshopper. For the bridge component, it's not free, so you might, if you have already SOFiSTiK Rhino license, then you can use it, update components, but otherwise you might not be able to use these plugin because it's paid. It's not free. Nevertheless, if you open, because I'm gonna upload this example file in the download link down there in my description box, and if you are interested in, you can, with a small donation, you can download this link, this Grasshopper script. Otherwise, you can only, if you are just interested in transferring RhinoInside part, this part you can just use it without SOFiSTiK plugin. So I mean, this already you can learn something for how to create family components in Revit using Grasshopper. Alright, let's go back to original component. So I wouldn't explain a lot of detail for SOFiSTiK bridge component because it's quite complex. It takes like maybe whole day to explain, and SOFiSTiK organizing well for their webinar. So you can also have a look their webinar or SOFiSTiK homepage to go through each detail. But basically, we can create the section of a bridge decking area using JSON file that we can also create the access, load access with this bridge component. So basically I'm creating load accesses and also the variation of the bridge profile that I'm using in this case Excel datasheet. So we can bring the data from Excel file so we can give this variable distribution points. And then we're going to interpolate all these cross sections, and the pier we're going to create some geometry for the pier, and these diagram I'm creating here is a little bit redundancy, but anyway, just simple grasshopper work, just deconstructing VREV and reconstruct connecting, extrude and couple and union, solid difference. And then here we have web shear keys or slab shear keys for the bridge keys. In this case I just create only points location, so we can later on interpolate those points to display adaptive components. And then we have here post tensioning attribute using post tensioning component, and we can also have a tendon. You can create tendon using SOFiSTiK plugins. And all these components they are going to be connect. So there is anchor and tendon box opening and etc. They are all created using Grasshopper, standard Grasshopper in this case. And then the bearing sits and also bearing position, all of them is created in this script. So when you look at it here, these are the final output of our parametric bridge. And this bridge is basically, as long as we change the parameter of what is given here, it will update. Just because of the recording time, I wouldn't change the parameter yet. But if you, we can change just to demonstrate. I'll change this here, the radius of turning point, and when I change the parameter, Grasshopper will recalculate, and it will take a little bit of time because the script itself is quite complex. But just focus on here in perspective model, and you can notice that the geometry will be changed after calculation. So as you can see, it changed, and it's still calculating the script, so it will take a little time. I'll just pause it probably until it finished calculation. So now, as you can see, it just finished the calculation, and then the geometry is updated accordingly, and all the components related to the bridge, they beautifully updated parametrically. I'm just gonna put it back to minus 300 millimeter radius in this case. Now Grasshopper is recalculating all the geometry once more. Because the component output we're going to use is not mesh geometry we're going to use, but we're going to use actual VREV in order to create really clean family geometry out of your Grasshopper definition. So that's why the calculation time takes more time, because the bridge itself is quite large span, and it's really a lot of detail inside. So anyway, the important thing is a parametric bridge that we can control all the details. And now when I go, all this data is organized once more for each geometry, as you can see. and they are, for instance, tendons. They are going to be you know output into data output components here, so we can always actualize whatever we change from here. They will be actualized in another script in RhinoInside part. Okay, not only this construction model you can do. If you use SOFiSTiK plugin, you can also use you can convert this parametric bridge to analytical model, and so you can calculate in SOFiSTiK. But this part, for this tutorial, I'm going to skip that point, and let's go ahead to now RhinoInside part. So when you look at here in RhinoInside, we have here the data input out of main source script. Main source script means that we I'll just hide it, this views. From this grasshopper main script, we create all this geometry, and they are now hooked up in this data output component. And like same, we can set our destination points, destination file path, and that file will be always synchronized to RhinoInside script. So let me go back to RhinoInside here in this case. So here I just did a little bit of graphic things. We organized each category to be look nicer, and this graphic settings we're going to use to create Revit material basically. So let me show you. In this case, we use material name we create from the panel according to the geometry we have here, and they are going to be formatted and concatenated and creating the material name, and also all the material colors we're going to reference from basically these colors we have already. So the Grasshopper and Rhino preview here, what shows in this color, they're going to be created as a material color of Revit. Okay, and also we have here all the hatches for the components, and they are going to be, now we're going to set material identity and then material graphic and appearance asset for the material, and all this output from RhinoInside material property going to be replaced our material asset in Revit's project data, and they're going to be assigned to all the components we have here, create loadable Revit family. Alright, so, and also family name going to be using the same control panel to distribute all the names to there. Unfortunately, we don't have a bridge template yet for the Revit family template, so we're going to use Autodesk need to work hard. They will sure provide bridge template in the future, but at the moment we don't have bridge template for the family. Anyhow, we're going to use generic model solution, and all these generic model going to be distributed to each RhinoInside component here. So it's quite large script, and I just don't want to delay the time. So let's turn off the preview, and all the material we create is still remaining there. And right now, as you can see from here, it's locked. My script is locked, so we don't actuate in Revit. Now I'm going to back to the Revit our Revit file. This in this case, Revit, we don't have anything. It's completely empty file, and let's create our bridge model by enabling all the components. So let me open Grasshopper again, and here what I'm doing is nothing complicated. We just use the BREP output from main script, and that converts to the family, and then we assign this family type to create component at the location, and then we can set parameter for perhaps for the IFC export and things like that. So here I define IFC export as parameter, so we can export them to be correct IFC entities. Unfortunately, right now IFC we going to use in Revit because IFC4 is still controversial. I'll use IFC 2x3 model view definition, and for that we don't have a bridge category. I think Building Smart is working hard to provide infrastructure category in the future in IFC5, but yeah, unfortunately we cannot use infrastructure category or IFC entities, so we're gonna convert them as a building entities. So this is a shear key and the bearing. I leave it shear keys and bearing part at the moment as it is, and let me enable all this loadable family category, so we can create. Let's enable them. So we're going to create all of them as a generic model and assign to each category. Alright, so each script they are just repeating, it's nothing special. All the geometry they are repeating the same script from here, and it just generate the components. So now I'm going back to Revit, and let me recompute. So now our script is proceed. So let's see it right now. I'm just counting how long it will take to create all the components. So the RhinoInside is calculating all the geometry from Revit to create family elements. Wow. So basically, let me turn off also the preview from Revit so we can speed up the time a bit. It's still calculating some point. It's not finished. But anyhow, while it's calculating, I'm just gonna leave it a bit. After 1 minute, I just created all these components we have in Revit here according to the material, and as you can see, you know, all of them is created. So let me select, for instance, the tendon. It's created as a family, which is really nice, as you can see. And the piers, bearing sheet, everything is done there. And the rest of script, what I'm gonna create now is we can create this shear keys that using adaptive component in this case. Let me go enable only this part, and I'm gonna enable, and I'm gonna compute, and yeah, let's pick up adaptive components we need. So these adaptive components, I believe somehow it's not loaded in here. Probably when I purged it, they disappeared. Let me load the family. So let's go to Revit, and I'm going to put adaptive components. And now back to Grasshopper, and I'm gonna recompute one more time so we can synchronize the family just we inserted in the project to be appear in our Grasshopper definition. So now I can choose them, this shared key adaptive components, and one more time recompute so we can get the type. I'm gonna get the type that without points. Now these are ready, and we can enable the rest of part. In this case, I'm going to use 4 points, group of 4 points. You see group of 4 points location of the shear keys, and I'm going to create them with Revit elements. Let's go ahead. I'm gonna make it wireframe view, and let's go recompute. Now all the adaptive components going to be placed at the position of shared key. So I just enabled it, and it may take a couple of, perhaps adaptive components usually takes more time, and there are a lot of elements in this case, so I expect it may take longer time to place them. But anyhow, let's measure the time. It just started now. Just about to pause, they are finished, and as you can see here, all the shared, for example here, web shared key or top shared key on the slab shared key, they are all created now. Let me hide some of the elements here so you can clearly see more. You can see all the web shared keys are created. Alright, so that's beautiful. And what else left now? The bearing position we can create. So let me go back to Grasshopper definition, and in this case we're going to use position of of the bearing location. So when I turn on the preview and when I recompute, let's go to Grasshopper, and when I select the point, let me see it in Rhino view. These points, basically at this point we're going to place our family element. Okay, so these green points, they are bearing position. What I'll do, I'm gonna enable them and Revit bearing type 1, and at this point we're going to place the family. So here I'm showing above here, we use this loadable family component from Rhino.Inside, create Rhino geometry directly as a family, and then another technique we use here is to use adaptive component to place all these shared key position. And the last technique is we're going to use actual Revit family at the position. So this is add component at the location. Okay, so now I'm going to recompute, and at the position, that's wrong. Let me undo. Something is wrong, so let's go to Grasshopper definition. Yeah, the family wasn't correctly assigned, so I'm going to choose our load type. That's not there. Let me load it again. Bearing type, I'm gonna load into our project this family. Now when I go back to Grasshopper, I'm gonna recompute one more time and go to back and Grasshopper definition, and here now I can assign our bearing family. So bearing type 1, and compute one more time, type 1. So these bearings are placed, but the orientation at the moment is not exactly located correct position. It's just because, I mean, we could script that in order to place at the correct position, but I just sometimes the too complex script maybe takes longer time than manually doing it. So here I'm just gonna rotate them manually to the orientation, so which is not bad, Let's go quickly other position. But of course you can make your script 100% perfect, but you just need to think about which way is efficient. In my opinion, if there is not many objects like this, if it takes longer time to create Grasshopper definition, then in this case I prefer to just manually do this simple job, because we don't have many elements to do that, right? But if we have, like, of course, like a shared key position, if we have million of them, of course we should definitely make a script so we can automate this process. But right now I have only a few of them to do it, so it's finished, and we have now perfect you know, the perfect output for the bridge model. I'm gonna save this file just to be sure. Save this file format to at loadable file and failed to okay, file not saved. I cannot save it some point because that the other file is also opened. Let me close that and then now I should be able to save it. So loadable file family, and yes, I'm gonna override it. So now back to my script. It would be nice if I can explain all of this to you, but it's a little bit too long. I think the tutorial is going to be very long. So I just decided to show you the potential workflow. And if you are interested, then you can just download this script and you can practice on your own. So the good thing is we can parametrically create the material. So when I go back to Revit material tab, for example, and all these different material colors and the elements, they are created according to the graph definition, which is amazing because that tedious job to manually create this is also takes a lot of time, right? And we just create all the elements we wanted to have parametrically. This is the powerful point of using, I would say, using RhinoInside. This is really game changer, real game changer, and you know, like to create this kind of bridge, it's very complex. And what you can do more is that let me click one of this family, and because this is loadable family, which means we could actually change this family here, and then you know you could update the geometry. So if you need more level of detail, you can actually enhance it. Let me go ahead just to show you. I would like to create one short void extrusion at maybe, let me set the plane somewhere here, for instance here, and I'm gonna create now the void extrusion. So I don't know, let's just create something like that. I'm gonna make it small openings, I don't know, small cut out here, just to show you how it could work. Sorry, maybe this is better. Yeah. So the rest of them we don't need. And then yeah, I'm gonna move it just a bit here, just a bit here, so you can see we have here a little cut out, for instance. And this family I can load into project, and when I override it, then you'll be able to see now in this family that part is updated. So here, as you can see, the geometry is updated in there. So this, you can really continue enhance your whole Revit model according to, let me undo because that doesn't make sense. So I wouldn't load family again, but I'm just showing you that these are all possible workflow. And because we have in RhinoInside script, we assign the IFC export parameter from here, and all of them has different names, so you can check if they are assigned. When I go here, as you can see, we have IFC export as column, which is strange, but the column is correct in this case, and that it's a beam. And we have here bearing in this case. Bearing is not assigned because we, let me check, there is bearing elements, and all these elements, they should have been assigned as a member type. Okay, let me go and ahead one more time. Let's see if they are now having the correct parameter. Still didn't get it yet. Compute grasshopper. What is wrong? Yeah, element, the element. Yeah, nevertheless, I mean it should work, but some point. Oops, didn't get. Should have the parameter. I don't know, maybe it's here in this case as a column, which is correct. Let me see the other guys. For instance, this tendon. Yeah, they it's IFC member, and as you can see, this is the member type, shear key, and diaphragm. They are fastener type, and I know it doesn't make any sense to create so many diaphragm, but I just made it to show these variation of geometry also possibly can generate it using RhinoInside. So please don't criticize for this bridge engineering point of view, but just look at as a potential possibility. What I'm gonna do now, because this is a family, one more time, I'm curious now if we can create them as if, yeah, it's a concrete, so we can host the Reva, and I'm going to change that property when I click and override it. Now let me go ahead, create some Reva elements. So here there is a section. I'm not interested in this section. Let me go to site, and I'm gonna create another section almost parallel to the frame here, and I'm gonna go to the section, and imagine this is our section of our beam. I'm gonna make it to find view, and in this case, because now we set this as a Reva possible Reva hosted element, which means when I go to structure, and if I go to Reva, and I'm gonna, alright, so we have to load all the Reva elements. Let me go to English. I'm going to sketch the Reva instance, and let's sketch, okay, again, I'm not reinforcement detailer, but I'm just gonna draw within this Reva cover, just whatever it looks like, correct. Let's go ahead here, something like that. Yeah, I know it doesn't really make sense as a proper bridge, but nevertheless, I'm gonna just make it something like this. Okay, and on the middle point somewhere, probably these guys, I'm gonna mirror it. Cannot mirror, unfortunately I cannot mirror in this sketch mode. It's okay, for me it's just want to know if this is possible, right? So I'm just gonna finish, and perhaps let's make this to be, instead of single lever, I'm gonna make them to be multiple lever. So let's make it to fixed number, and I'm gonna make them to 15 of them, and these guys I'm going to show in our 3D visibility view as a unobscured, view as a solid and unobscured. And when I go to now 3D view, you should be able to see these Reva at the position where we just draw. So isn't it nice? So you can see these Reva element now, and also we have all these bearing elements. Let me just manually select them all, and because this is Revit family, I can say IFC. For that, I can say just at the moment member. Alright, So this bridge is done, and I'm gonna just export now. Let's see if in section, sorry about that, in your section, if these are all the dimension and everything could work. So you can see, go to dimension tool, and we can put the dimension accordingly, and all the spot, slope, and these are all working because it's our actual family element, right? Which is great. And spot elevation, if I go, you can see the elevation point is working. So drawing purpose, there is no problem. You can really go enhance your infrastructure drawing. I don't know, because I'm not really engineer. Just look at this as a potential workflow for you. Anyway, these are all working, and now I'm just gonna export this file as IFC model, and let's see that exported IFC would work well or not. So let me go to export IFC. We're gonna use IFC 2x3 option. Yeah, base quantity. Let me set that. Yeah, let's create a new one for this demonstration purpose. And I'm gonna use Revit internal origin. And yeah, we're gonna convert 3D view elements. The base quantity are included. And of course, you can, because it's a curved geometry, I'll make it high geometry setting, so we can accurately export it. And I'm gonna export now based on this setup to the IFC element. So let's go ahead. I'm gonna override it from here. Export. Yes. Okay, export is just done, and I just open in Solibri here. And if I go to my layer, as you can see, there is generic models, which is, these are all the the shear key, and we have here the bearings, and I'm going to click the plus, so diaphragm as a beam, and we have here another bridge bearing seat we created. And here, if you go, here is a frame, and we have here tendon. If I isolate, tendons are there, and here all the other parts that we need to work on. And the levers are also there in IFC format. So I think everything looks good here, how we expected. I just, maybe let's draw one section here in Solibri. So section, I'm gonna create using here sectioning. So if you draw the section, as you can see, we have really nice section in Solibri as well. Alright, I think for now that's it. If you have question, please feel free to put the question down in description box. And this example file I'll put on my donation page, buy me a coffee page. So if you're interested in, you can just with small donation, you can also take a look at the script. Just notice that the Solibri plugin for Grasshopper, you need to have Solibri license to use it, otherwise it wouldn't work. But RhinoInside part, you can test it if you download the files. Alright, thank you very much for watching it. I hope that brings you some idea, or it gives you some idea to work with a bridge model in Revit using SOFiSTiK plugin and for Grasshopper, and also RhinoInside. And if you liked the video, please click on subscription and like, and that way you can sponsor me to continue my research. Thank you very much, and wish you enjoy your RhinoInside, and thank you for watching it again. Alright, bye bye.